All right, in this video, we're looking at vertical asymptotes. All right, if it were possible to extend the graphs in these two figures, figure 1.40, towards positive and negative infinity, you'd see that each graph becomes arbitrarily close to that vertical line x equals 1. So we call this the vertical asymptote. This is not new. We know that as we approach unbounded towards this, we're never going to hit it. We're going to get infinitely close, right? That's what a vertical asymptote is. So we're actually going to define it like this. If f of x approaches infinity or negative infinity as x approaches c from the right or the left, then that line x equals c, that vertical line, is a vertical asymptote of the graph of f. So in example 1, we noted that each of those functions is a quotient and that the vertical asymptote occurs at a number at which the denominator is equal to 0. It's important to note that the numerator is not 0. Okay, so the denominator is 0, but the numerator is not. This next theorem that we're going to look at is going to basically generalize this observation. So we're going to say if f and g are continuous on an open interval containing c, as long as f of c is not equal to 0, g of c is equal to 0, and there exists some open interval containing c such that g is not equal to 0 for all the x's in c that are not c, then that graph of that function has a vertical asymptote at x equals c. Does that make sense? All I'm saying is if g of c equals 0, so that means that c makes the denominator go to 0, but f of c is not 0, so c does not make the top go to 0. Okay, if that's the case, then there is some open interval that has c in it such that g of x is not equal to 0 for all of the x's not equal to 0. So as long as, or x equals c, sorry. So as long as x's don't equal c, then these numbers don't equal, that function doesn't equal 0. It only equals 0 when x equals c. And that x equals c gives us a vertical asymptote. So let's look at this. Can we find the vertical asymptote? I certainly hope so. Basically, all you're going to do is take it and find there's no canceling out, no dividing out. I know that 2 times x plus 1 equals 0. I divide by 2. I get x plus 1 equals 0. I subtract 1. I get x equals negative 1. There's my vertical asymptote. Now, what about this? Here I've got x squared plus 1, which doesn't factor. I've got x plus 1, x minus 1. That does factor. So there's nothing I can cancel out, but I can see that if I let x plus 1, x minus 1 equal 0, I know that each one of these has to equal 0. So I get x equals negative 1, x equals positive 1, 2 vertical asymptotes. Lastly, cotangent x. And we've already talked about this. When we graph cotangent, we know that it has asymptotes every pi. Right? It looks like this. So I know it's got vertical asymptotes at 0, pi, 2 pi, 3 pi, negative 2 pi, or x equals n pi. So if you have any questions about vertical asymptotes, please make sure and shoot me a reminder or ask a question in class.